Okay, so one thing I wanted to do today was show you part two of the Si4707 and BeagleBone black setup. Part one just kind of showed you the hookup that I had, just the basics of the wiring and the usage of the radio module, the amplifier, speaker, that kind of thing, just a generic wiring. And the second part, I'm going to show you how we actually interface to it. And so the first thing I'm going to do is open up PuTTY. And I've already got the BeagleBone Black set up on my local network through an SSH connection over the Ethernet port on the BeagleBone Black. All the communications for this program currently are set up strictly through SSH. There's no serial port or UART interface off the BeagleBone Black that's utilized. So we're going to go ahead and load this up. I tried to make the PuTTY screen as big as possible because the video quality wasn't working out real well on the screen capture. So hopefully this will work out okay. It's just I got a log file that it records to, so we'll bring this up. I'm running the Ubuntu installation, so I'm going to log in as Ubuntu. For those of you doing the Angstrom installation, I believe it's just root, and then there is no password. Then once you put the files that I'll provide later on the website onto the BeagleBone, you just want to go to that directory of where you've put those, and then run the python nwr same.py. I'm sure that there's a way we can get around the whole having to put in the password every time. I just haven't got that far yet, so that helps if I put in the right password. Okay, so the 4707 is starting up, and then it's loading patch data, and then as you can see we've tuned to 162.55, and you can hear the broadcast. One thing I wanted to go over was the at the startup sequence, you can see that just like in the Arduino, it'll come up, say, starting up the Si4707, but between that and the menu display down here, you'll notice that I put in some debug information, and that debug information, I just kind of wanted to explain that a little bit. It comes in here and says loading patch data. Now, the Si4707 without a patch has a tendency to produce false alerts. And what I mean by that is some of the responses in the software will tell you from the chip that it saw an alert when it really didn't. So Silicon Labs has a patch that you can load into the chip that corrects that problem. So the next thing I did is print out this revision information. The revision information actually contains the patch ID. So after the patch is loaded, by printing this out, you can see that the hex number of Delta 195, that is the hex that you should get if the patch was loaded correctly. So that's just kind of a way of knowing that the patch loaded up correctly. And it gives you a couple of other pieces of information here. And then the menu, the normal menu, comes up just the same as it does on the Arduino load. After the menu pops up, I put a little more debug information into this one just because I was doing so much testing. So directed frequency in the file that I had for the unit to come up to was 162.55 megahertz. Again, some debug information, tuning. Once it's done tuning, comes up, reports the frequency and the signal strength and the signal to noise ratio. It has the same type of operation as the Arduino build does. D for down, it tunes down off frequency. U for up. M for mute. M again to unmute. Now the scanning feature, what I did with the scanning feature is actually made it print out the information as it went through each frequency. So it's a little bit different. It'll show you that it's tuning to each frequency and report the signal strength that you get off of each frequency. So you can tell that as it went through, it saw that 162.5 actually had a stronger frequency, and so when it was done, it tuned to 162.5. The reason that it's stronger than my local frequency broadcast is that I've got a signal generator up to run a quick test, since I don't have a way. I just missed the weekly test this morning, so I wasn't able to actually capture that on video, but I wanted to just show you that the BeagleBone Black actually does the same type of parsing function that the Arduino load does. So I'll load up a test here. And so, as you can see, what I did on this one was I actually had it print out the string of the message. Looks like the S dropped off the end. Probably a couple of things I need to change on that before I put the files up. But what that does is that allows you to actually see the complete string, and then from the parsing operation that occurs down here, you can tell what pieces of information are contained within the string and how they correlate. So I just thought that was kind of nice to be able to see the whole complete string and then see how the program broke it out. So you've got the originator, what event it was, how many location, counties, FIPS codes are affected by the alert, and then it breaks out the actual location codes, the duration of the alert, day, time. The day, time, and duration is just that. It's just dummy data that was put in for the test mode. But normally in a normal alert, you'll actually get how long the alert is for, the date and the time that it's occurred, and then the call sign. This is just a dummy call sign that I made up, and then the end of message detected for the final 3 bursts. Now, normally in a normal message, you will get the 1050 hertz tone that comes across, and you will see that the alert tone indicator will print out in between call sign and end of message detected. You'll see that the alert tone was detected and that it's on, and then it'll tell you that the alert tone is off. So hopefully I can capture that data, but it should look exactly the same as what you would see with the Arduino load. So one of the things that I'm playing with before I actually put these files up is to provide a way, because we have the ease of the internet connection through the Ethernet port on the BeagleBone Black, is to, when this alert comes across, to have a function in there that will allow you to send that as a text message to your phone or to an email address. Utilizing, for instance, for my BeagleBone Black, I set up its own Gmail account. So I can log into my BeagleBone Black's Gmail account, send out a message to my phone and to another email address, and it will pop up. So once I get that implemented, I'll provide a video of that operation as well. All right, thanks for watching.